And hello, everyone, and welcome to Mobility and Connectivity COE panel. I'm very excited to be here and extremely pleased to lead this panel discussion today. I would like to welcome our panelists who are domain experts and industry leaders in IoT. So today's panel is quite special because it's all COE members. So before we jump into the discussion, I will go around and let the panelists introduce themselves very quickly. I can start with myself. I'm Divya Gupta, Senior Solutions Architect at SAS Global IoT Division. My prime focus revolves around providing architecture design solutions to customers and partners in the IoT sphere. I'm also spending time deploying real-time streaming processing at the edge, where edge to me, it can be any gateway or an IoT device, but must have enough computing resources to run SAS event stream processing. I'm also quite involved with the streaming analytics, both at the edge and the cloud, and have been dealing with intermittent connectivity issues. So today we will share our experiences and knowledge on the same, and I hope this panel discussion will be very educational and informative to our attendees. Since we have two members with name Todd today, so I will go with Todd Beets and simply Todd for Todd Spraggins. Okay, let's go in the alphabetical order. So Bob, do you want to go first? I know, I just fumbled there.
It's all good, all good. Yeah, Bob Proctor, co-founder and CEO of Link Labs. We are focused on asset tracking and monitoring, primarily in the manufacturing and logistics space, both indoors and outdoors. So hyper precision location and tracking indoors. I call it affordable precision, as well as using everything imaginable outdoors. And have a lot of experience with coverage issues and intermittent connectivity and edge processing and all that. So looking forward to the conversation today.
Great. Todd Beets, do you want to go next?
Sure, thanks, Divya. Todd Beets, Director of Product Solutions at Synadia Communications. Longtime architect in high tech and retail. At Synadia, Director of Product. And Synadia, we're working with many customers in our community, the NAS community, on next generation location transparent microservice communication. So anywhere to anywhere, edge to cloud, cloud to cloud, edge to edge, trying to make those composite solutions, those composite applications, ever more easier and easier to manage.
Cool. Jeff, do you want to get next? I think I made the order. I messed up with the order here.
Manage. Jeff Bruce Payne, I'm with Inmarsat, Director of Innovation and Technology Partnerships. Inmarsat's a global satellite network operator with offices around the world and coverage around the world. My team within Inmarsat works with some of our new customers and innovators who are developing solutions that need satellite connectivity and specifically IoT applications that use satellite connectivity.
Todd.
Hi there, Todd Spraggins with Oracle Communications, Strategy Director. We're oversee our portfolio, our interactions with outside organizations as well as internal, and where we're focused on communication, enabling things like IoT and bringing communications to the cloud.
So, like just to start with, we all have been working with different customer use cases and dealing with connectivity problems. So, would you like to share, your experiences with these problems and also the use cases that you're dealing with, and also the challenge that you see and what impact that is having?
I'll jump in.
Sure.
And maybe stretching IoT a little bit to sort of the generalized edge compute, because you kind of, at least we see the patterns of what used to be IoT in sort of the general edge case. So, for instance, large retail customers with essentially a fleet of stores or a fleet of point of sale units or things remotely. more and more, there's more of a complex microservice-like solution that makes up that sort of edge solution for like a retailer. And there's sort of this dynamic mix, more and more dynamic mix between some microservices in the cloud that are doing specific functions. Maybe it's policy enforcement like anti-fraud, or maybe it's just plain old payment auth. And then you have your local, where the actual human customer is, you have your local services. And so more and more there's sort of an interplay between cloud and edge. But of course, what happens when the cloud part of your microservice composite solution goes away? What are the things that the designers at the edge need to think about, and what are the trade-offs? Very similar for us when we're working with EV customers. When your car or whatever it is becomes disconnected from the cloud, or even a factory floor, some 724 mission critical factory, where there is an interesting, complex, and rich solution involving cloud and edge components. But when that cloud sort of blinks away for a short time or a longer time, that edge solution often still needs to work. So that's the core challenge we see.
Yeah, there's like two things here. If sometimes the cloud services also change, and the edge, whatever the way you were using it has to be modified now, so it doesn't work anymore. And also reconnecting is a big issue for the edge devices back to the cloud. Mm-hmm.
We see similar use cases. So likewise, we have point of sale solutions where we're finding that you have to enable the platform, the edge platform itself, to be able to assist the applications in understanding the connectivity state and how to deal with it. And so that might include, not being able to do cloud-based authorizations on the credit, and instead doing some sort of other policies, storing the credit information securely until it can be brought back up to the cloud later for processing. Putting different policies in place when there is connectivity versus when there isn't connectivity. But that works well when you know that you're dealing with a back end that can tolerate databases that may not always be in sync consistent all the time. Where you do absolutely need that, we're finding that we have to go one step further with connectivity to the edge, and where we've taken technology from our SD-WAN portfolio and enabled what basically is multipath. And so you can do things intelligently, like potentially switch carriers, have multi-MZ, multi-SIM with EUICCs, or actually multi-technologies. And so treat it as an overlay to technologies like cellular, the LP-WAN, or satellite, or even Wi-Fi. And when you do that, I think the most fundamental thing you have to keep in mind is making certain that the application isn't burdened with having to understand those intricacies, and that your platform itself sort of makes all of that messiness disappear. And all they need to really worry about is what kind of mode am I in, so that my application can behave properly, and not that I have to, as an application, manage all these intricacies.
Yeah, and I think it also depends on the use case that you have. For example, if it's an agricultural use case, then the cellular connectivity might not work, and you might need to have low power, low range WAN, and that might be the best solution. So it also, I think, depends on the use case itself.
Yeah, I'll add to that. In the asset tracking space, we do a lot of what Todd said. It couples into, are there networks available of any form? One cellular carrier, another cellular carrier, Wi-Fi, et cetera, even crowdsource that you potentially could rely on depending on the application. Do you want to install an LP-WAN? You kind of need all of those techniques to create. If coverage exists, can you ride on it, I guess, or utilize it? And then if coverage doesn't exist, can you augment it, is the next question. Then you get into really the data rate questions that come up with, particularly the LPWAN technologies are very data constrained, which takes you into edge compute. And you've got to kind of put all those together and understand, how much edge compute do you need in order to essentially only send state change information, back up to the cloud, and how much can you buffer and surge into the cloud and all those types of things. So I think edge compute, coverage infill or augmentation, plus fallback or multimodal communication all starts to matter, particularly with mobile assets.
Yeah, we see a lot of the same, Bob. So obviously in the satellite space, people that come to us have a fundamental connectivity problem that they're aware of before they get there. But yeah, many times we're augmenting other forms of connectivity, and a lot of it's just that finding that balance between what this network technology can do versus that network technology. And there are a lot of parallels in some cases to what you mentioned, like the low power wide area technologies. In some cases, satellites are very similar to that. And again, a lot of it's down to determining what the critical information you need is, when you need it, and how that data helps you make decisions.
Yeah, I'd like to, I thought the comment from Todd was interesting. I'd like to underscore it too, and that is sort of how little can you share the pain across your sort of complex application at the edge. So if you have reduced connectivity, or maybe you have a augmented connectivity with a connectivity switch, or maybe you just have a cut that, that famous backhoe or what have you, maybe a sunspot in the satellite case. How, as a designer of the composite solution at the edge, can you either rely on certain technologies to isolate the rest of your application from that blast radius of having to know about connectivity right now? Or can you design your data and your access in a way that you have a certain set of microservices that really handle that and have certain sort of limp home modes, or can do smart things to limit the complexity throughout the rest of your functional application stack as a designer? I think that's a key issue in many use cases.
Yeah, that's correct. And would you like to share also the approaches for achieving resiliency in the face of intermittent connectivity and the challenges with those approaches? Todd, you can just continue here.
Oh, sure. Well, it's I come from more an application in a messaging space, and so I'm not as much of an expert in failover and alternative networks. So I'll let other panelists talk about that important strategy. I think we're more focused in what we do with customers is really on asynchronous communication, which can still mean service requests, expecting a reply, but it's all asynchronous, as well as sort of publish, subscribe, and sort of end-to-end messaging cases. And so there's sort of a core design ethic that if you can design with some of these patterns, then you also have the opportunity to put some dynamic state in the middle, a data stream or a message stream or something like that. And then if you have the tools and the controls to sort of dynamically create that as you need and place it on your edge, now you have some of the classic sort of store and forward ability. So the ability for your edge application to stay functioning, to do its thing. Maybe it's creating telemetry data, it's recording transactions, whatever it does. And then when the connectivity comes back, it just automatically synchronizes to your cloud streams or what have you. So there's a lot of design tools, and especially if you're using the right patterns and applying some next generation technology, that the designer of an edge solution can really, sort of in many cases survive even complete connectivity cuts for some period of time. Ultimately, physics is physics. So I think the sort of the role of the designer and the architect becomes more important to make those trade-off choices, risk versus reward for whatever the function is.
I think it's also depends a lot on the edge itself, how powerful it is, what all we can do there, how much computer resources it has, and based on that,
Absolutely.
we can decide, what we do at the edge and what should go to the cloud or on-prem. So it's really important what edge we have.
Yeah,
Right.
that's important. Some of the things I think, I know we work with a lot of customers, and our technology is of a lightweight footprint, because you're right, in some IoT or edge cases now look like pretty beefy little machines, some resources, technology is grand, cost reduction is grand. But it's always more difficult when you have a fleet of these things to manage to do, some kind of database or a store or something like that. Whenever you have that state, state is the S word, right? It just increases the complexity of management and cost of resources. So the more we can make that lightweight, dynamic, easy to manage across a fleet of things, the more we can give those designers some of those classic tools, even in a small footprint.
I think that's spot on for the design of a lot of modern software today. With cloud, you sort of expect the worst case. You don't always understand what else is going on with your cluster, and so people have started building things with eventual consistency. It's highly asynchronous, but I think there's also places where there are real-time communications at play. Absolute state synchronization is mandatory, and in those kinds of situations, you have to put technologies in place, redundancies, put overlays in place to where, and then it's not always just a cut. It can be things such as you get some sort of RF fade, with something that's moving, and so you've got a link that is not always consistent, and so you've got to somehow figure out how to smooth that over time, and that could be rate limiting, or putting extra technologies on top of encoding, so that it may take more bits to get the message there, but you know that it gets there reliably. Those are kinds of things that you can add onto the links based upon the scenario. But I think a lot of the applications that we see that aren't real-time constrained, we find that your typical cloud behaviors around eventual consistency becomes really important here. And those that know how to play in that world typically aren't all that shocked when eventual consistency doesn't happen. People are used to programming with timeouts, and what do you do when things time out, and how do I as a microservice survive when I'm disconnected from the thing that I need to. Those encounter within the cloud, and so when it becomes external, I think some of those same behaviors and good, we'll call it programming hygiene, play really well.
Yeah, I think this is more important for mission critical applications rather than applications that can still survive with consistencies and discontinuous network.
Yeah, I would build on that. We kind of break the world into, can you provide coverage augmentation because you control the site or not? And then also between, what you might be doing in a site or a campus-based world where you might have some control and you can use sort of the LP-WAN or mesh type technologies. And then what do you do sort of with the network operators? And within that, for security applications, for example, and safety solutions, where we often do look for different types of there's redundancy with any given type of system, so like a LoRa or a mesh type technology. So, with LoRa, we'll add extra gateways. So if a gateway goes down, everything still functions and you're monitoring that infrastructure. But you can fail over to a totally different sort of architecture from LoRa is typically a star topology to a mesh topology using a different type of radio, sort of spectrum and backhaul in that segment. And that creates a lot more resiliency if you can manage that kind of failover to a different type of architecture. It means you have two different types of chipsets now in your infrastructure and in your edge devices. So it gets more expensive. And it comes back to what you said, Divya, in the beginning of the use case. Is like if the use case is security or safety, sometimes that you build the business case for that level of failover and resiliency, whereas in I only need to read a meter, once a day. I can deal with the intermittent. You store it forward later, right?
That's true.
That option is actually coming to 5G. So so I'll tout the 5G flag for a moment. We're seeing it's starting release 16 and then 17. The ability for the devices to be able to talk to other devices and sort of create a mesh relay system is something that is coming. And I think that people are always talking about the low latency and then tons of machines and all those other 5G things. I think this may be the more obscure one. It's not going to be easy to manage, and those who figure out how to manage it are going to win. But that's a brilliant example of being able to go from your traditional view of a point to point to now a relay based mesh with a technology that's at our fingertips.
Yeah, in that case, these devices should be possible to support different connectivity possibilities, and they should be able to use different options there, right?
Yeah, although with what Todd's saying on the 5G, we're pretty excited about that as well. Is it just creates a different backhaul modality, so that if you're not close to a cell tower, you're hopping there, and that starts to really augment coverage. Now you may only hop when some other mobile devices, can create that kind of, fill that gap and create that. So you still have to have some ability to deal with latency and intermittent, sort of, storage and edge processing to sort of manage all that. But it starts to add a lot of capability, within a single radio technology, which is pretty interesting.
Yes,
that's right. Jeff, would you like to add something as well?
Yeah, well, I mean, just kind of layering on what everyone else has said. A lot of ultimately, in our experience, it all comes down to the business case, and there's a wide spectrum of needs, right? So you have, certain end of the spectrum where they're dealing with, one set of needs that might be very critical, and then it's a question of there might be a fine tuning of some of their business requirements in terms of how often do I need to refresh this information, and they kind of iterate that into a monthly operating budget for that use case that pays back, right? So sometimes it can be as simple as reducing the amount of data I need or how I send it. Sometimes it's getting more creative about what data I send and how I send it. And then there's a lot, with edge computing is advancing quite quickly these days. There's a lot of really cool other technologies that are coming into play that are some really clever approaches to doing things with, data compression, and machine learning and other things all layer in. So there's a lot of cool stuff happening out there, and it varies widely with the use case.
Oh, cool.
Yeah, I mean,
thinking...
it often strikes me as is at the end of the day, it's a business decision, because if you have augmented network and all these cool things, of course there's a cost and complexity to that, as is there to local state and things like that. So what is that business's or business use cases appetite for stopping? I mean, there's always a stop point. What we can't do is guarantee that connectivity is always there. We can make it better and better. So what is the stop point, and how much money is a certain business use case willing to spend to not have a stop point in that service? I often think of a car. Cars are now modern little data centers and things like that. And at the end of the day, if the electronic brakes and the algorithm and all the controls don't work, there's always a fail-safe to stop the car or not allow the car to move. So there's a stop point. There's always a stop point. So what is the stop point for some IoT or edge solution? And what's the
Yeah, so
level of complexity and cost that we want to spend on that?
So Todd, taking it forward, so would you like to talk about the fundamental application design decisions one must be, considering the business requirements and the trade-offs around the discontinuous network-dependent microservices outage? You have been talking about the microservices part, so maybe you can show some light on that.
Yeah, I think that the panel today is kind of hit it. I mean, to me, there's really two levers. There's as a designer, putting ourselves in the architect's shoes who has to create some business solution at the edge. What is my lever or my expectation that some kind of networking is usually there of some quality, and sort of making that could be hard to judge. So there's all the solutions where, okay, I'm going to assume to a certain level that there's network here because I have failover and I'm using a cool satellite thing and life is good. And I may not invest that much effort at all in trying to recover from an intermittent because the call is made, the risk call is made that network is going to be good enough. You see that even in cloud solutions. I mean, all of these are sort of distributed computing solutions. In cloud, there's often an assumption if I have enough stateless workers, it's going to be pretty rare that I can't find a live one. And so you make certain architectural calls. So the same thing has to happen at edge. How good is my network? Do I have network backups? And then it's like, well, I know I'm always going to have the risk of no network, no matter how many redundancies I have. That's just physics, especially at the edge. It can happen in a cloud data center as well. And then for my use case, how much complexity do I want to add and what technologies can I do to reduce the cost of that complexity in management? And mostly that involves some sort of either alternative business logic, what I like to call limp home. Maybe if I'm a microservice that does anti-fraud policy and I give approval decisions to the other microservices in my edge cluster, maybe when I don't have connectivity, any charge less than $30 goes through. So I'm protecting the rest of the edge application from that intermittent connectivity issue to say, a cloud fraud service. Or it might be, no, I need to actually have some local buffer, local state, the cache, etc. So I need to manage state at my edge so that I can keep running either with a cached version of reality, kind of digital twin, or just I can be autonomous and function at the edge. So these are the kind of things that the designers are facing. And it really varies based on, again, what is the cost of stopping?
I think you have to look at the cost from two perspectives when building the business case. One, there is the cost of how much am I willing to invest to get to the risk level that I feel comfortable with, which is what Todd Beets has been talking about. But I think that there's an operational expense as well that you have to factor in. And that one's sometimes a little bit more difficult to understand because satellite costs differently than cellular, which costs differently than an LP-WAN. There's also different tariffing schemes, and depending on if you're roaming or not, and these get extremely difficult. And again, I think relying you need to be able to rely on a platform that not only abstracts the technologies, but also sort of abstracts the commercial sum so that you can, take that risk tolerance and use it to understand how much you're going to build your application around these, but also take that risk tolerance and understand how much operational expense you're willing to have. And hopefully have a platform that allows you to manage that operational risk just as much as it enabled you to manage your design risk.
Yeah, I think when it comes to connectivity for IoT, one solution doesn't fit all. So, and given that we have so many various options from cellular, Sigfox, LoRaWAN, Bluetooth, long and short range wireless. So with all these connectivity options, which have their own benefits and trade-offs, and also we have to consider the data transmission, how much amount of data we want to transfer, what's the frequency, the latency, power consumption, security part, the cost part, and the risk as well. So based on that, we need to really think what exactly is the trade-off here. We want what is our requirements. So said that, it is very important to choose the right connectivity solutions for what our business use case is, right?
Yeah, and I would just add or emphasize that I think the architectural levers, as you hear people talk, are pretty broad and robust that we have to play with. And it really does come down to, back to the business side and the business decision of, architecting a solution that fits it within the business requirements. And I think, anyone in the audience today that's like, can this be architected to provide a solution? The answer more often is yes. You can pretty much do anything now. There's a very robust and relatively, and constantly evolving, but, fairly mature, I would say, toolkit today relative to, even a few years ago. But the question always comes back to, well, how much business value am I going to unlock? So I'd like to really push, our customers towards, let's start to talk more about how much business value do we think we can create here? And then, sort of put a bogey out there for the architect to say, you have to, you have to kind of come into this cost profile with these types of requirements and challenge them to solve the problem for you on the architecture side.
Or it's like, just make it happen.
Right, exactly. Abstract away all this complexity and just give me a nice clean data pipe. Right.
From a business transformation perspective, you'd be surprised how much is being left on the table. We're sitting here wringing our hands over these extreme use cases. The reality is just even getting the simple intermittent connectivity is a boon to tons of businesses, and I think we need to make certain that we don't scare people off here, and that the simple is oftentimes 80% of the battle, and it's amazing what connected IoT can do for business transformation. So I know we're talking a lot about all these intricate details on how you can do really extreme use cases, and they are out there, and they have a lot of business value to the right customer. But I'm also shocked at how many people just really aren't out there connecting things to the simplest levels and harvesting that business value.
Yeah, well, let me just, wow, I mean, couldn't agree more.
That's a great point.
There's so much demand out there for perfection, which is the enemy of good, and the good here has huge ROI, and really important to emphasize that.
Yeah, I agree. I was just thinking as we were talking about, I think a lot of developers, a lot of solutions providers, they're sort of under this sort of both a constant desire as a designer and pressure from their business, because much of our technology ecosystem has been very refined to the sort of web and mobile, where you have a human being on the other end, and plenty of technology, network and failover and stuff around that. But ultimately, you have a human being at the other end who often is trained to ignore intermittent errors, or hit the reload button, or just throw up their hands and go, "Oh, that's the modern world. I'll try again later." There's constant failure. There's constant intermittency. It's interesting is sort of many of our use cases, we don't have that human at the other end of the intermittency. So it just means as designers, we have to sort of figure out what we want or what we want to do for the use case. And as Todd Spraggins was saying, I agree. Sometimes it's like, do nothing. for this use case, it is what it is. We're going to stop for a while, and then it's going to start up later. In other cases, you need to get more fancy, but it's a great point. You don't have to overdo it if the use case doesn't require it.
Yeah, and there's an
Most
awful
of them.
lot of tools at our disposal for as I think several of the other speakers talked about. There's a lot out there, and it's not a question of whether the technology can solve the problem. It's mapping to the business needs.
Yeah.
Yeah.
I think the
and
best way
another
is
way
to
to
make
think about
our
it.
edge intelligent to solve lots of problems.
Yeah. Another way to think about it too is, we sometimes break use cases into can you make a lot of progress statistically? Is 90%, with 10%, we may never get the data. How much business value does that unlock? I always talk about security solutions before. Obviously, you don't want a security solution to work 90% of the time, but if you're trying to find lost pallets or glass racks or those types of things where the loss rate is extremely high, and there's tens or hundreds of millions of dollars on the table with 90% of statistical coverage. So it's you really got to start to think about, what do I really need, and is good enough actually great?
Yeah. Yeah, we're also moving towards the edge intelligence. So would you like to talk about the ways edge intelligence can help when the connectivity is a problem and a challenge?
Yeah, I mean, I'll start. I mean, certainly we find that with mobile assets where we're largely focused, edge intelligence is critical in part for not only for the intermittent connectivity, but frankly from a cost perspective as well. A state machine at the edge really can be leveraged to keep you from essentially using battery when you don't need to use battery, which means the device lifetime could be a lot longer, which if you're tracking thousands or millions of things, right, that replacement cycle is really important in the business case. And then in these what I call sort of purpose-built IoT network technologies, the cost of data transport is actually quite high. And understanding the cost of data transport in a state machine at the edge can be really valuable in bringing those costs down to something very reasonable. So all in all, we see it as almost critical to have for mobile assets a state machine at the edge to basically say, please transport only useful information rather than everything.
Yeah, most of the data analysis can happen right at the edge, and we just send out only the data that really needs to go to the data center or to the cloud, and it can also help to maximize the business efficiency.
I would just add that that's not limited to mobile assets either, right? So similar principles. A lot of cases, what we deal with, obviously, there is no other connectivity option, and a lot of these are managing things, industrial control systems, and in the middle of nowhere doing an industrial process, and you still get similar value there for making sure that what you're sending is really what's important to send.
Yeah, I can't emphasize enough the ability to do all that pre-processing on the data, the filtering of the data, the cleansing of the data. Yeah, you can do those things in the cloud, but when transport becomes expensive or not always reliable, being able to do that on edge. And we're finding also that the amount of being able to do the actual AI models, running them locally, is becoming extremely beneficial to a lot of use cases. The only thing there you have to worry about is, I think we're just still discovering what the trade-off is on, you get model drift. And so there's a benefit of still sending data back into the cloud so that you can, continue to train, because you may not be able to do continuous training on the edge. That may not be something still feasible yet. You can run the model, but you can't do the more advanced things that require more compute and other resources than what your constrained environment allows. And so it's a balancing act of maybe there's a new feature that's popped up. Well, the cloud's the best place to discover that, but somehow you've got to make certain that the data, the data for that feature is actually now being sent to the cloud, and that dynamic of constantly rebalancing what gets sent to the cloud versus what doesn't is a challenge I think we're still grappling with today.
Yeah, I would underscore that. Certainly, Synadia and we see that this is really sort of the killer app. I mean, we view the killer app of this decade and in the next as really, how do you do at grand scale that sort of digital twin? Sometimes we say the avatar pattern or what have you, where you have 100 million robots or a billion. They're all somewhat autonomous with some level of edge intelligence, and they want to have a sort of an active but intermittent conversation, with your clouds and other services around the world. They may not always be online, as Todd Spraggins says, but you still want to have a conversation with them. So how do you, or you want to update them, or they want to update you? This is big. This is not just a IoT thing. This is gaming, massive gaming as well. So how do you do that at cost? Obviously, we have examples where we do that today, but it's huge cost and complexity. So how do you drive that down in cost and complexity and make it more ubiquitous? And a lot of it goes to classic IoT concerns: large fleet sizes, autonomy, expense of the edge devices, communication redundancy, all those things. It's a very mainstream. I think it really is the killer app of today, distributed computing.
Yeah, that's true. And but I think overall, if you have edge intelligence, then it can decrease the likelihood that the data will be intercepted or breached. And additionally, it would give the business, it will make the business more self-contained and do not have to rely potentially on the faulty network connections and to do their work. So having the edge intelligence can also be very helpful. And I agree with the points that you just mentioned, but at the same time, it's just an upgrade, to your whole cloud, edge to cloud and back. Yeah. Jeff, do you want to add as well?
I don't think I have a lot more to add. I mean, I think that the points have been well covered here. Edge is very important to us. The filtering of data, the management of that effectively. We are, as a satellite network operator, we are part of the operating costs. I think Todd Spraggins was referring to in terms of the OpEx model. And yeah, ours tends to be more expensive than other options if you compare it on a like-for-like basis. But drawing back to oftentimes, good is great, is that you can make subtle changes to things and still have a very cost-effective and immediate business payback from what might otherwise be perceived as something expensive.
Yeah, that's true. That's true. Yeah, and I think as well that if you upgrade it to the intelligent edge technology, we might be able to manage with our revenues, the increased revenues, the cost, and also might save money over a long term. So it might be a wise decision to switch or to incorporate intelligent edge. So going forward, so we just have like a minute left. So I don't know, maybe we want to have some question from the audience, or we can also discuss about what are the limitations of relying on, cloud services, since we're talking about the edge intelligence. So are there any limitations with the intermittent connectivity?